Good morning to everybody. It's once again a pleasure to be with you on this fresh late autumn morning. And so this morning, thanks very much. We're going to talk about the battery. It's a part of the car that's quite often overlooked and misunderstood as such in what it is. So without further ado, let's have a look at. We're going to have a quick look at what the purpose of a battery is. What is a battery? How does a battery work? Designs of batteries, casings of batteries, electrical system, the charging system, and the starting system. And included throughout that process, we're going to talk a little bit about problem-solving issues that might occur and so on, and see if we can just highlight what the value of the battery is. So the purpose of the battery, it has three main functions. Obviously to start the vehicle and to provide the ignition system with power so it can be cranked and started. The second is to supplement the electrical load when load requirements exceed the supply capability of the alternator. So it also supplies loads to the electrical system, the parasitic loads when the engine is switched off. I'll talk a bit about parasitic loads right at the end of this presentation, just to bring that into perspective, and because it's one of the main problems that we often have with batteries in the market. And then it acts as a voltage stabilizer in the electrical system, where the battery smooths out or reduces temporary high voltages which occur in the system. Now, typically, you'll know that when you jump start a vehicle, everybody recommends that you switch on the headlights and you switch on the aircon and you switch on as many systems as possible. And that's to try and smooth out any spikes that may come through when the vehicle starts. Now, the battery is a typical absorber of those, but in the event of the battery being flat and you're doing a jump start, that battery is not performing its task in that manner, and therefore the purpose of it is that you put on all those auxiliary systems to absorb any spike loads that may come through at the time. But under normal circumstances, normal operation of the vehicle, when you have your headlights on high beam and you have your aircon on, etc., and you suddenly switch them off, there's a load relief on the system, and it can lead to a spike in the system, which could potentially affect things like ECUs and body control modules, etc. So the battery is there for that purpose as well. So just a quick view of a couple of batteries, normal vehicle car batteries and some truck batteries on the right-hand side, different layouts, different polarity positions. And obviously, these are not unfamiliar to any of us. So the point really is just to illustrate that there are numerous different shapes and sizes and styles and values. But all automotive batteries are basically 12-volt batteries. Where they go into 24 volt, then it's multiples of these 12-volt battery cells that are put together. And you might see in some of the bigger trucks, they might have 4 batteries together. That's not necessarily making it a 48-volt system. It's making it a 24-volt system with two pairs of batteries in parallel, giving you a much higher amperage, which is obviously valuable in cold starting conditions with a big diesel engine. So what is a battery? Battery is when you have two dissimilar conducting materials, electrodes, and they are dipped into an electrolyte, which would be your acid, and there's a reaction between the materials, the electrodes, and the electrolyte, which causes a conducting of chemical mixtures, and those chemical mixtures create the electrical current running between positive and negative terminals, and the whole unit is called a cell. Now, when you connect the cells, you cause an electric current to flow through the wire from negative to positive. So there's a couple of different ways that this is done. Primary cells, such cells are termed primary or non-rechargeable. These primary cells are similar to your torch battery, where there is no possibility of recharging it. The material degrades and degradates to the point where it eventually is no longer working, and it cannot be recharged. Secondary cells, such as the lead acid, we get absorbed glass material batteries, we get lithium ion now, and I certainly don't want to go into the chemical principles of lithium ion or absorbed glass material. But the lead acid belongs to the group termed secondary or rechargeable, which is what the AGM and lithium ion batteries fall into. And that's because you're able to regenerate the stored value of the electrolyte and rejuvenate the cell panels within the battery itself. So we talk about primary cells and we talk about secondary cells. Our automotive batteries are all secondary cells because they can be recharged by reversing the current into them. So fundamentally, when we start the vehicle, we draw a high amount of current from the battery, and when once the motor is running, the alternator restores that current back into the battery by reversing that flow, and the intelligent charging system then determines when the battery has reached its full capacity, and the alternator will then either switch off charging current, or it will divert to the running of the vehicle so that it becomes a closed system. In terms of cell designs, just quickly having a look at a couple of different designs that there are out there, and some of them more modern than others. There's the rectilinear, which is the very old-fashioned style, the radial, which is the third one in the line, which was a more modern design. The center lug radial was very effective, but then along came the tree design. The tree design was the most recent, and when I say most recent, probably in the last 40 years. So it's in terms of battery terminology, lead acid battery terminology, that is probably the most recent. And the principal theory of it being that the current that is generated across the grid needs to find the shortest route to the lug. Now, as you all know, electricity will always find the path of least resistance. So by creating a direct linear direction to the lug, there's obviously less resistance, so you get a better delivery of current out of the tree design of the cell panel. So battery ratings, something that's often misunderstood. The cold cranking performance, or also known as the CCAs, cold cranking amperage, it's the discharge load in amps, which a battery at minus 18 degrees can deliver for 30 seconds while meeting the following requirements. And followed by a rest, and then another load at 60% of the original until the battery falls to 6 volts. Final requirement is to be met within 40 seconds. So it's quite a complex test that gets done. It's quite a complex process, but fundamentally the principle of the cold cranking amps is that it's to ensure that the battery has sufficient capability to crank the motor and start it when it's minus 18 degrees Celsius. So the principle being that the colder the motor, the more difficult it is to crank it. Now, where we sit at normal ambient temperatures of, so let's take a rough guess, in winter, we might see a 0 occasionally. It's not sustained below zeros. So the batteries at a CCA are quite capable of being able to start the vehicle, providing the battery is in good condition. The reserve capacity is the number of minutes a new fully charged battery at 25 degrees Celsius can be discharged at 25 amps to a minimum voltage of 1.75 volts per cell. Now, bearing in mind that a automotive battery has 6 cells to it, which makes up the 12 volts. It's each automotive cell is basically supposed to be in the region of 2.1 volts, which is your nominal voltage, but they can go as high as 2.7 volts, which brings you up to the 14.2 voltage capacity of a fully charged battery. So that's, in other words, you would be discharging a battery at 25 amps to 6 times 1.75. So that would be your bottom voltage across the battery itself. Then the 20-hour capacity is the same thing, how long it can maintain a voltage of greater than 1.7 volts, and that's expressed in amp hours. So that's just a quick explanation of the different ratings across batteries. So the effects during discharge of a battery, i.e. when you're starting it or using it in a different way, is that the acid decreases in its strength, the specific gravity drops, and I'll talk a little bit about specific gravity in a few minutes. The specific gravity changes, the plates, the acid reacts with the sponge lead on the negative plates and the lead dioxide on the positive plates to form a lead sulfate. That sulfate, and you've often may have seen people talking about batteries being sulfated. Now, when a battery has become sulfated, it is because the battery has been abused and the sulfate has been allowed to generate to a point where it cannot be restructured. So in charging a battery, and we'll talk about it just now, the battery, the sulfate during a recharge gets redistributed back into the sponge lead and into the lead dioxide by rebooting the acid in the mixture, the electrolyte. The other product of the chemical reaction is water, and ultimately what happens when the battery discharges is the specific gravity goes down, the acid decreases, it becomes more like water, and unfortunately water has a lower let's call it a higher freezing point than acid does. So if you've discharged a battery and you're in freezing conditions, the chances that you could freeze the electrolyte in the battery are increased as well. So temperatures, high temperatures increase the chemical reactions, thus the available output of the battery. But too high a temperature can also shorten the battery life. And it can go into an overload situation where the plates can warp if you draw too much current too fast out of the battery. And low temperatures result in the acid becoming denser and slowing the chemical reaction down. So hence in winter, you will find that a battery that is marginal, when the temperatures drop, the acid process becomes slowed down, and hence you suddenly find on a very cold winter morning, your vehicle won't start, and that's because the acid in the battery has now reached a point where it cannot deliver at the required level to create the current that you need in the current draw. So the effects during charging, obviously the electrolyte is being energized, recharged. The voltage of the cell, as you pass current backwards into the battery, from the negative back into the positive, you create a reaction called hydrogen gassing, and this occurs once you reach 2.38 volts within the battery cell. Up until then, the battery stays stable. If any of you have looked at a battery being charged when the cells are open, and seen it bubbling and seen gas coming out of the battery, that's because the cells are reaching above 2.38 volts as they charge. And the voltage charge will reach approximately 2.7 volts toward the end of the recharge of the battery. And I'm talking about specific cells now, not a total battery. And then one of the things that is critical during charging is that if the current passed into the battery during charging is too high, you will charge the battery quickly, but you will also overheat the cells at the same time. And you can run into what is called thermal runaway. And thermal runaway can cause an excessive boiling and gassing from the battery. And it can also cause the battery to explode. So it's important to charge at the correct amperage and maintain that that amperage without allowing excessive heat to generate in the battery. I have personally seen batteries explode in charging facilities, and in my part of my career was with a battery manufacturing organization, and we often used to have batteries exploding in premises where they were being overcharged. The other thing that one needs to understand when charging a battery is that the charge rate must not exceed the battery's capacity, because then you run into what is called an overcharged battery, and basically you destroy the battery's internals. So a charger needs to be calibrated. A charger needs to be delivering what it is showing. I've seen over the years numerous battery chargers stating that they are delivering 5 amps, but in fact, when measured correctly, they're delivering 15 or 20 amps, and that leads to an overcharge of a battery. We had one instance where a business was continually complaining that that the batteries that they sent in for claims were being rejected for overcharge, and it so turned out that that particular business's battery charger had not been calibrated, and where they thought they were doing a charge at 5 amps, they were actually doing a charge at 25 amps, and they were literally destroying all the batteries on their charging bank. So it's quite an important thing to bear in mind during the process. Talking about specific gravity, and specific gravity is the ratio of the weight of 1 liter of sulfuric acid to the weight of 1 liter of water at the same temperature. So what it means is that when your battery is fully charged, you would have 1.27 value of acid to water in the battery. So you have less water than acid, and so it's your battery is fully charged when your SG is showing 1.270 on the float level in the hydrometer, and a hydrometer is obviously extremely useful in testing the battery's values. So as you go down, your state of charge on the right-hand picture, specific gravity at 1.220, your sulfate ions begin to lodge in plates as the specific gravity drops, and your battery is starting to deteriorate quite rapidly. When you get to a 50% state of charge, you are starting to fail the battery, and the specific gravity shows at 1.17. A fully discharged battery is at 1.070, and you can see the volume of water in the battery is nearly in the picture form almost 100%. So it's a case of the dilute is completely incorrect now, and the electrolyte cannot perform the function of creating the chemical transfer between the sponge lead and the lead dioxide in the process of generating the current for your battery. So the point of this picture is really to say to you, if you test a battery at any point in time, an open cell battery with a hydrometer, it should be above 1.220. If it's below 1.220, your battery is starting to get into a bad state of discharge, and you should be taking remedial action around that. So battery care and maintenance, a battery should be kept clean at all times. Folks, a battery that's dirty with grease and grime and road muck and so on top of it, all of that can carry moisture, and moisture can carry current and cause a discharge across the battery itself, and leave you stuck between a rock and a hard place when you most need the battery to perform. So keeping a battery clean is a critically important part of it. A battery should be kept correctly charged, as I've said earlier, and the battery should have the electrolyte kept at the correct level. Obviously, this is not in a closed cell maintenance-free battery. I'm now talking specifically to open batteries that have cells that can be opened and checked. And also, as a caution, whenever you top up a battery, the electrolyte, you top it up with distilled battery water. Don't add acid to a battery, because you will destroy the battery internally, because you'll increase the pH level to the wrong level. And a battery should not be exposed to excessive shocks or vibrations. Excessive shocks and vibrations to a battery cause the sponge lead and the lead dioxide to expose more to the acid and to actually break off internally. The lead is, although it's malleable and can bend a bit, it also can break off, and that's why it's advised to keep the exposure to shocks and vibrations limited as best possible. Battery care and maintenance, I spoke about cleanliness and the moisture carry. The electrolyte, the term maintenance-free, indicates that under normal conditions, the battery should not require topping up during its design life. And then again, further down, acid should never be added to a battery unless there's been a spillage. And if there's been a spillage, you have bigger problems in terms of making sure that that acid spillage isn't damaging other components, especially if the vehicle is in the vehicle. And then the final one, which is quite important to note if you do have an open cell battery, is that if there's excessive water usage, could indicate that the alternator's voltage regulator is set incorrectly. And the voltage regulator is the thing that determines whether the battery keeps charging or not. Sulfation, I spoke about sulfation earlier. If you operate the battery in a low state of charge for lengthy periods, you allow the battery to stand in a discharged state for a long period of time, or leaving a battery for long periods without regular charges. That'll cause sulfation, and it'll cause permanent damage to the battery, which will not be able to be recovered. And insufficient charging will also cause permanent sulfation, because the temporary sulfate is not completely removed from the plates during charge. So effectively what it does is it ends up with the plates of the battery being covered in sulfate, and the sulfation is very, very difficult, if not impossible, to remove from the battery, thus rendering the battery US in its form. So leaving a battery idle for a long state of time, we spoke about that, the specific gravity too high. If the specific gravity at 15 degrees exceeds 1.3, it'll result in a chemical reaction. And so that's what happens when you add acid to a battery, as opposed to adding distilled water to a battery when the electrolyte level is too low. And I also spoke about overcharging earlier, where overcharging is usually accompanied by heavy gassing, which dislodges the active material from the positive plates. Now, what I mentioned earlier just now regarding the alternator, if the alternator is overcharging, that'll cause heavy gassing. The gassing is actually water vapor that is coming out. It's a combination of hydrogen and oxygen, and that gassing can also be extremely volatile or flammable rather, which can also cause an explosion and fire in a battery if it's overcharging. And the overcharging also leads to higher temperatures. Common causes of failure: overcharging, undercharging, deep discharge. So if you use a battery for your camping that's not a deep cycle battery, it's going to lead to permanent damage of the battery. Cycling the battery, running it down to its minimum continuously and trying to recharge it. The battery only can do that so many times. Over tightening the clamps is a logical one in terms of damaging the battery, and the incorrect fitment of the terminals. Now, this is quite important. Never, ever use a hammer or a spanner to knock your terminals on to a battery, because you can damage the solder connections internally in the battery with that vibration of banging the terminal onto the battery. So it's a point that if the terminal doesn't slide on properly and tighten correctly, clean the terminal, clean the battery clamp, and make sure that they fit properly without excessive force or hammering onto it. Preparation of a new battery, obviously check that the specific gravity is above 1.25. I said 1.220 earlier, but preferably it must be above 1.25. remove the old battery. Always remove the earth terminal first. Never just remove the positive. The earth must come off first, because that then basically isolates the vehicle. Make sure your cables insulation is intact, and if they are not, replace them as serviceable items. And then the installation, the earth cable should be connected to the battery last, and make sure that you hold down that keeps the battery in the vehicle. It must be snug. It does not have to be tightened to the point where it cracks the casing of the battery, because that's completely unnecessary. It must merely snug the battery down into the battery tray in the vehicle component. So now moving on into a quick bit of troubleshooting around the process. One of the greatest causes of battery, or what we would call incorrect battery failure, is when your starter or your alternator have their bearings failing. Now, when you hear that a vehicle is battling to start and it has a very slow starter that turns over a little bit and then it stops and it chugs and then it will turn over slowly and then suddenly it'll go again, and everybody thinks, oh gosh, the battery's dying, you're probably finding that your starter motor bearings that are on the front of the commutator and the rear are actually worn out. And what happens when the bearings wear or fail even, is that the armature will pull skew, and it ends up grinding against itself internally in the starter. So it'll give a half a turn and then it'll pull against the field windings in the starter motor, and that'll lock it up. You release it and everything goes back to position, and you turn the key again and it'll turn a half a turn and it'll lock up again. You release, and then maybe you're lucky and you get it and it swings past that locking point. But that's very often, I mean, people claim that would be, oh, my battery's failing, my battery's ruined. In fact, it's not. They put in a new battery. The new battery's strong and it's got all the current it needs, and it swings past that blockage. But a day or two later, back to the same thing. And guess what? The battery gets the blame. The battery by that point is now getting damaged because it's having to draw more current through to the starter than it should require. And consequently, the plates in the battery and the electrolytes start failing. And all it means is that the battery is trying to do what it's not meant to do, and it's trying to overcome failed bearings in the starter motor. Similarly, in the alternator, the other side of the coin, the alternator bearings can also cause the alternator to scream and make a noise. And then also, if it's not running smoothly, not running straight, the charge current that the alternator delivers can be affected, thus not recharging the battery fully during the driving cycle. Or if you see on the bottom right-hand side of the picture, there's the regulator. It's a little plug-in item, and it's a very easily replaced item. If that has failed and it's allowing too much current through or too little current through, then your alternator is not doing what it's supposed to do. And guess what? The battery gets the blame again. And that's ultimately where we go into this process. Check that the systems in the vehicle are doing what they're supposed to do. Make sure that your starter motor is working the way it's supposed to, and that the starter motor can't last forever. It also has a lifespan. The alternator bearings have a lifespan. The regulator also has a lifespan. Make sure they're working, make sure they're doing what they do before the battery gets the blame for being at fault. I mentioned earlier that I'd talk about parasitic drain. Parasitic drain are the items that run in the background when the vehicle is switched off and you're not even in the car. So your burglar alarm in the car, your immobilizers, GPS trackers. Now, those are standard items that continue to run. However, we've had many, many, many instances where a vehicle's battery is being blamed, a vehicle's battery is being regarded as rubbish, it doesn't last, it fails, but the parasitic drain from the immobilizer has reached a point where it's drawing on the battery so hard that it's actually flattening the battery overnight. And the next morning, the battery's flat, battery gets the blame, but in fact, the mobilizer is actually doing the damage. And the vehicle gets jump-started, gets driven for the day. Overnight, the battery's flat again. Sound system installations, these are all aftermarket things. Sound system installations, auxiliary lighting, those can cause systems to degrade. You have leaks in the power system. We've seen where spotlights fitted to a bakkie have been, although they're switched off, there's a leak of current that the bulbs are drawing slight current during the off period. It's very slight, but enough to discharge the battery and leave the vehicle in the lurch when you need to restart. Bad earthing is also not so much a parasitic drain, but bad earthing is something that can cause a battery to present as being discharged because you're not getting full current through on the earth circuit. So it's important that the battery is correctly earthed and that the full earth current or negative current is able to flow into the vehicle to allow starting and running of the vehicle. Obviously, an old wiring loom where you've got leakages in the wiring loom, cracked and perished insulation. Obviously, we would refer to this as being more so in a vintage vehicle, but in abused vehicles, if there's been a fire in the engine bay or something, this can also still be a cause of loss of current from the battery during the parasitic process. And then dirt, as I mentioned right at the outset, dirt across the battery can cause a parasitic drain of the battery and leading you to be left in the lurch when you need to restart the vehicle. So in conclusion, batteries and components have a lifespan. Batteries have internal components that can wear out. They do wear out. Although batteries that are very carefully maintained during their lifespan can have a very long life, they also, under typical normal conditions, do have a finite period of time that they'll last and they will die. Inspect your battery at least monthly. If it's an open cell battery, get the electrolyte checked once a month. It's good value to test it before it's too late. The last thing you want to do is when you are out in the evening or early morning and you're in a hurry and you put your key in the car and you turn the key and it goes nowhere, and then it's too late. So testing your battery monthly, keeping an eye on the battery is worthwhile. And when changing the battery, as I said earlier, when I showed you the pictures of the starter motor and the alternator, make sure that all the other systems are correct. And once again, for the best value, do the job properly every time as well. Because if you do the job properly, you will have the best value out of the battery. So keeping it clean, making sure the alternator and starter are doing what they're supposed to do, that you don't have parasitic drains into the vehicle, will make your battery last. And then together we can help keep the spark in your wallet and from blowing your fuse and to help you charge your profits. So without further ado, from myself, Hedley Judd at the Tire Equipment Parts Association of the RMI, I thank you very much for the time, and I really appreciate your attendance at this session on a Monday morning, and I look forward to chatting to you guys again sometime in the future. Good luck, and thank you very much. Have a good day. Stay safe.